Alright, we're going to work on our 45 stroker motors here finally. So this is my mock-up motor over here that we videotaped a while back. So this is basically my Sportster mill crank in here. But this is our pop-up here. You can see how far it pops up. So this got a stroker crank in here. So that's basically what we're going to be doing to this motor over here. So got two of these to do. So this is the stock case, all cleaned up, ready to go together. I mean to start working on it. And this is the right side over here. These are our new main shafts, new crank pins, one set of new case races. These are the seals for the crank. We'll go right over here. This is a genuine Harley race. This is import shit here. And this is the 4-vein rotor here for the oil pump that they make now. Put in the oil pump and make them hot rod our oil pumps. Whatever that up to. And then we got our stroker flywheels here from Truett and Osborne. So we got that. So these flywheels here are made to take Sportster rods, which are here. This is a stock 45 rod. So it's the same overall length. Takes the same rust pin, takes different crank pin. And they're a little bit wider. A little bit difference in the width here between that and that, as well as obviously the size for the bearings, and the beam for the string. So we're going to put the updated rods in there to get more out of it. So that's where we're at right now. So I'm also going to put rollerize the lower end here. I'm going to put roller thrust bearings in here instead of stock washers that just eat themselves up. So I'll take a side load and won't hurt the crank. So I got to take these case races out, and then I'm going to cut them and play with them a little bit, because these are just, I'll use these for mock-up. These are our new Jim's ones over here. These need to be cut down also for my application. So I'm going to cut this set here up too. I don't think I'm going to use the genuine Harley, this aftermarket crap right now. I don't like this India shit too much. So I'm going to go, for now, I'm going to get another set of these, and I'll have two complete cranks I can do then. So that's where we're at now. Here you go, Rick. Don't film my feet too much.
No, I won't. I will.
That's what you said last time.
Yeah, well, I told you don't believe a thing I tell you.
Alright, so this thing is flywheels. Those are heavy.
Only if you pick them up.
They look new.
Don't tell nobody.
Well, we don't know if they fit yet. We'll find out. They can only afford one bolt, not two. Get twice as many done this way. A nice bolt there.
Yeah. Use that for engine stand bolt.
It's a nice American bolt. We'll keep that for our engine stand bolt. Except there's no washer with it though.
Yeah, but it's only for an engine stand.
Yeah, there you go. Yeah, they're stuck together. Evidently they're made in Wichita, Kansas. Jeez. Oh, I would never thought that.
That's where they're shipped into.
So we need to get this pin out of here somehow. So that we can make up a different bearing setup. At some point we're going to have to balance these.
Should be able to drive the pin out through that hole.
They're not balanced. What hole?
Nope, not that hole. Excuse me.
You have to show what you're looking at here, sir. What were you pointing at there, Ricky? This hole here, you mean?
Yeah, I was wrong.
Or are you talking about the big hole in the middle?
No, I was talking about the little hole.
Oh, the little hole in the middle? The one that's right here,
Yeah,
not over there?
Well, I was wrong.
You were wrong. You sure?
I'm positive.
Positively? Okay. What about that hole there?
That's a
whole nother hole. Alright, so we gotta play with those a little bit too. The first thing to do is get these case races out of here so that I can go butcher them. I need some testing tools. And then we take these genuine Jim's parts over here and cut them up too. I don't have any problem at all cutting up these parts. There we go. Should have cut easy, I bet. Okay, how are we gonna get these out?
With a press.
With a press? That's called corrosion. Evidently got corroded at one point. So I need a pressing tool. That looks kind of like that. How about this one? Looks like it might work. It goes on this side too.
I'd put it on that side.
Okay.
Yeah, but no,
Press it out with this side?
I wouldn't know.
You don't know? There's an eraser right here. We use that for a sample. Yep, that's the right size. Okay, let's go try that out, see how it works.
Movie.
You didn't want to go all the way. Okay, there's one I used to play with. See how it's got the factory muck on the inside of it?
Yeah.
There you go. That's a good one. Case looks good. That's always a good sign.
Scooby. Scooby-Dooby.
Do the same thing in this one. I'm going to make sure the bushings are below the surface. There they are. Oh, that's tight. We have to see if they make an oversized one now. See what they make Loctite for, right? There's that one.
Yeah.
It's like new, huh? Okay, these two are ready for machining. These two need to be machined. Okay. What's the difference in height between these? About 82, 92, 55. That's terrible. And nothing.
Not very much.
It was into 40. Okay, so I can't cut those down that far. So it looks like I have to cut these things down quite a bit to make them usable. So it looks like I go down to about at least 82 because that was our thinnest one, which is the left side one here. So we'll cut these the same number, that way I can use these as mock-up. Figure out what this is going to be. And push these back in after we're done. We got to cut off. Oh, is that all? About 80 thousandths. Yeah, cut easy, right?
Yeah. Harden, you bet.
It's only a little hard.
You grind easier.
Interrupt to cut too? I don't look real good. So what bit we gonna burn through?
A few of them.
Sounds like you've done this before.
No?
I'm thinking that this side right over here looks like a perfect candidate to be used.
For a while.
It's already broken and screwed up. That means that'll be a great cutting surface. One thing about carbide, it'll burn through anything, just about. It just takes heat and pressure.
I really thought they were harder than that. Thanks. Turn blue in there.
Only blue. Give it a hard spot. That's hard a bit. Getting there. Thinking the bit's getting a little dull.
So we got that little junk in there? Yeah, a little bit.
It needs more heat. Or I gotta sharpen a little bit. So I'm thinking a little sharpening wouldn't hurt. What do you think? Think it's bad?
Nah.
We'll fix that problem. See how that works. So what'd I do?
Sharpen it
How?
on the grinder.
Duh.
Well, you hit all the edges. And
Cut the nose down real flat, and I put a negative on the front. Negative for high pressure applications.
Yeah, we want a positive.
No, you don't.
You're always negative.
That's right. I think I'm going to clean the crap out of the cutter over here. Except it's kind of welded in there. So under high pressure applications you go negative. See if that's any better. What's the difference?
Still there.
I didn't get it yet. I take more off.
Still gotta take more off.
All good.
Yeah, sharpen it one more time.
Still there. Where's that spot at?
Right there.
Find it? Might be a little sharp on the inside. I'll have to get my die grinder over here and knock that out. So that's what you do to a $100 race. You butcher it. So we came in at 71 thousandths. Nice and flat. I'm going to take the genuine Harley one. Now, do you think the old one's going to be easier to cut or harder to cut than the original repot Jim's part?
It can be harder to cut.
A lot of times it is.
Good?
got fluff. Hard there on the inside, on the edges. You think that bit's dull yet?
Yeah.
Yeah, we're down to 105. 35 more to go. Is that enough?
No, it's still there.
Down to 80. 83. No, this one's a lot deeper. It's not going to go away. We got to take off another 12 hours. Six, 70, 73. We need a little, maybe another resharpening job, maybe? Think that's well used? Do you think it looks different this time? How's that look this time?
Looks like it's broke.
Looks like it's gone. How about that corner there?
It's
Pretty
gone.
nasty too. Yeah, there might be a sharp edge on that though. Let's see how bad it really is. It might still have a little life left in there. maybe not. I think the newness went away real quick. All right. That bit's getting worn out. We'll try one more resharpening on it.
Kobe, tell us what the world's about.
No food. More warmed up.
What's up, Scoob? What's up?
Thou too far there. Get fired now.
Tell me a markup.
So which one's harder to cut?
That one.
The Harley one's.
Well, I told you that.
That old metal's a lot better than that new metal is.
Better heat treated.
Just goes to show you Jim's doesn't have the best crap out there. They only say it's the best. Doesn't make it the best.
There it is. Isn't it? No?
Yeah.
Yeah.
Close. I think it's cut all the way through, it's just there's a hard spot there, right on the surface.
Yeah.
Have to grind it to get it flatter. See the hard spot right there?
Mm-hmm.
This one is 80.
You know why it's harder, don't you?
I know that's harder.
I do too.
That's 10 power thicker than the other one. It's harder because it can be.
Well, because that's where that notch was.
Yeah.
And the heat treat went in deeper.
The depth of the heat treat's the same no matter where you're at.
That's not true.
Same depth. Inside the same crap. Same depth. This is a hard one. Definitely hard. Do I cut that much already? Shit. Oh, that's not good. What did I measure?
You were in the notch.
No wonder I'm so thin right there. Now I gotta cut a lot more now. It looked like it was thicker than that. 10
what I
pounds.
would, what I would have done is allot. So that went over to my
Grinder and ground it.
die grinder and ground it. Magneted it down and went zoop, 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 zoop.
Yeah. I don't have that. I think I'll take that fine concrete grinder back there and go out there. It wouldn't be very flat.
No.
You would have put a lot more heat into the part. So they took all the heat treat out of it. The part's actually cold. The chips are hot as hell. The part's not hot at all. Thinking this bit's getting dull, what do you think? See, those are not red hot. Don't measure right there. We got 9 thou to go. Not much. One. That sounded like it broke off, didn't it? Tortured that side a bit. Enough. How bad's it going to be? Oh, I can see why that wasn't cutting for crap. We'll go over this nice new surface over here. It's almost as bad. That side might look like a piece of crap. Same height now. That one.
Ooh, that's nice.
It's hard. Okay, I'm gonna go back and grind the ID out and clean them. We'll be back.
Okay, here you are. On the script.
We're in the script. There's a script for this?
Yeah, the script. And did you read it last night?
No, please forgot about it.
It's all in the manual.
It's in the manual?
Manual, yeah, you know.
Manual did it?
Manual did it.
There we go. She's installed. Same one that just came out right back here.
That's made in Taiwan, right? We are in Taiwan, aren't we?
That's enough.
No, we're in Mexico.
Now we're going to do this one.
Same thing.
Nope. Push on it like a real motorcycle. Unlike the new Harleys, you can actually push on these damn things. That's one problem. This isn't flat.
The twin cams are like the new generation. Not much to them.
These ones you can actually put pressure on without breaking the case. That new stuff, you couldn't do this crap with it. It would snap right in here.
You got any of those new brand new Indian motors apart? They any good?
I don't know.
I was looking at them the other day. I was thinking about buying an Indian one day.
Oh, a new Indian.
Like a 2006.
You mean a Gilroy Indian? That's an SNS motor. Yeah, that's a good motor. Well, that's probably actually the Indian motor. That's a pile of crap motor.
The Indian motor's a pile of crap motor?
The round one? Yeah, the round big one.
Yeah.
Alright. Who wants me? Hello. Hello. Maybe. Okay. I'll take a look. Alright. Bye. Alright. So now, these still have the titties in there, which means we can't use them, but it's the same height as the Jim's ones, which don't have titties in them.
Yeah, I'd just skip on the bearing. It would hurt it.
Yeah, that's not good for the bearings. So we have to figure out what we're going to use for bearings, but something over here might work. We're going to wind up using thrust bearings like these right against that surface. See how that one's not quite big enough?
Yeah, not quite.
What are you filming, my titty over here?
Yep.
That's good.
No extra charge.
Same charge?
The girls might like to look at it.
So now we go to the bigger one. See, ooh, that's a big one there. See, that one looks like it might actually work. See, we don't know what we need until we need it. See, look at that. See, that is the correct size. So that gives us a thrust bearing. So I'll have to get some more of these. It's like 1 1/4 inch.
Why can't you just use a shim on there and then a thrust bearing?
Because I don't know how many shims we're going to have room for. Because remember, we have to work on the other half of the flywheel. This side. This isn't an easy thing to figure out. So, but see how that looks like that fits in that hole?
Yeah.
So this might not be that hard of a job.
Well, then you put a shim in there to make it hard.
You are going to need a hardened shim for the inside, yes.
And one on the other side.
Don't need on the other side. So they make these in different thicknesses. So, but it looks like I am going to have to machine the flywheel a little bit bigger to put that in there. Because these are a lot bigger than the bearing.
Well, just cut the...
Whew. What have you been feeding that dog?
Come on, man. Get out of here, Scooby.
Oh, jeez, I can't breathe now. Jeez. Jeez. Yeah, Rick.
It wasn't me. That was you.
Jesus Christ.
That was a Tatro.
I can't
It
breathe.
might have been your dog, but it was still a Tatro.
I can't breathe anymore. Oh, jeez. Ah. Ah. Surprised I didn't yellow to get a haze in here. The clips inside the billet here.
Did.
Jeez, that's horrible. Here, that looks like the right size. See, look at that. Fits even better. Oh, look at that. That might actually even fit in there. Now, we are going to have to make it fit so it doesn't rattle back and forth like that. So So we're going to have to come up with some way of keeping that from happening.
I would just take the bigger one and turn the outside down.
And we're also going to have to go thick enough that we don't touch that. But see, that won't happen because, see, that's too big. So that's fine. So we have to take that pin out somehow. How hard do you think that pin's going to be in there?
Well, it depends. Slide hammer and
You got a slide hammer for that size?
not here.
Think we'll get lucky?
Maybe. I doubt it.
No. Think that's going to screw up my new pliers? Yep.
I know it's going to.
Yeah, look what I did on my new pliers. See, even though you pay a lot of money for pliers, these are Whirls, they're still crap. You know, chip that right off. So that is a heat-treated pin, obviously. I have to come up with a different way of getting that out. Have to work. I'll have to figure that one out. We could try to weld something to it and pulling it out.
Yeah, you get weld splatter all over.
Well, we just cut the damn thing out. They're not worried about it. I like that one.
Yeah, cutting out better than welding.
I already screwed up my pliers. Now I need a new pair of pliers. Those were new. Oh well. Okay, so we'll grind that pin down. It doesn't matter if we'll do the dimple down because as long as the washer sits flat. And it looks like we can start adding material from there to here. Now we cut a bunch of metal off of here, so we can have shims.
How much did you cut off?
The first thing I got to see if I got any washers that work for that. See, these washers are for probably big twin because they're bigger. So. These appear to be all big washers. So I need some more of these little small ones like this. That's another big one. Yep, that's a big one. There's a bearing. Washers. Something. Ooh, some of those. Well, that's a different looking bearing. That's a big bearing. See, big bearings for big washers. See? That's for big twins, panheads, knuckleheads, important stuff.
Important stuff.
What's in here? Nothing. We have a whole stack of these with a special tool. I had to make those. So you use that's a knucklehead UL sprocket shaft. You put that in your lathe and tighten it down, and you tighten the nut against it, and you turn it down. And you make a nice washer. Look at that. It didn't even fit.
Oh, is that what you do? Put that washer in there?
This is what I use on big twin when I modify big twin stuff. So we're going to have to come up with a different setup for the 45 motor. So we're going to have to figure out what we need. So I already say I got to order up some parts. So we need some 1¼ inch washers to do that. Now this is going to go around the sprocket shaft. Where's that box of crap we had over here? Yeah, that pinion shaft was over here. Crappy pinion shaft. So that goes there. Look at the precision fit that is. Think that's a shaft or the flat one?
I don't know. I used to have to take some of those old flywheels and lap them in. But people told me I'm not supposed to do that. But I did anyhow. It seemed to work for me.
Okay, so this goes like this. And then we have to figure out how much material we're going to have left over for a thrust washer. Now you got to remember, a thrust washer goes in there, factory. This here used to be thicker, now it's about that thickness, right? So we cut off of this is the thickness of this. So it's not like we have a lot of extra room here. So we can play around with this washer here in different thicknesses, but when these only come in every 15 thou, it doesn't leave a lot of room for playing. So that's going to go in there and stack in there just like that. What I have to make is I have to make something that will keep these from rotating like this, because that will destroy them.
Why don't you just drill a hole in it?
Right through the bearing?
Yeah. No, through the thrust washer.
What's that going to do about the bearing going back and forth? It's going to go out here like that, orbit around.
Well, you make a little spacer.
Correct. So we're going to make a sleeve spacer that goes in between the shaft diameter to hold the washers. So that's what I got to make. That'll give me an adapter piece. So that's the project for tomorrow or next week. So right now I need to go buy some washers because I don't have any washers. I only got one. So it looks like we can use this diameter washer and this die here, bearing. Now if I put a Harley thrust washer in there, that would work, but the problem is it's soft. So this bearing would chew up the Harley thrust washer, put metal throughout the motor. This is a hardened washer, it doesn't wear. So we have to make Harley, we can't use Harley parts. So I'll have to go find me some washers. So tonight we'll be studying the catalogs and figuring out what we need. Luckily we got the, these are 60 thou thick. So I'll go hunt down some other bearings, some other washers, and order up a bunch of stuff. So that's how we figure this stuff out for now. So next time we're going to go ahead and we'll grind this away. We'll get the rod set up in here, mock it up, and see if it fits in the cases. And we'll see how much in play we got. That's why I put these in here, because they're already fitted. So I can just put bearings in there, slide it together, and do a quick mock up. That's pretty much how this motor's put together. It's just mocked up over here. So this motor's just mocked up too. It's just got loose bearings with used parts. And you can go ahead and put together, see how it all in plays all work, and then you can see how much stuff you got to cut away, like up to here. Now I already cut this case out for this crank stroke, so I can take that case apart, mark my cases right here, and go cut the cases for the big stroke, and that'll fit too.
Why did I cut the flywheels down?
Cut the rods down? I cut the rods in half.
Oh, not the rods.
The rods are what's hitting.
Oh, okay.
So we'll make it all work. So anyway, that's it for tonight.